Hello, my name is Andreea-Elena Drăgnoiu. I'm a PhD student at the University of Bucharest, Department of Computer Science in Romania. And my PhD thesis consists of using blockchain technology for software identity maintenance. So what is the research question behind my thesis? It is how blockchain technology can be used to maintain digital identities, because nowadays there are a lot of digital identities. Some of them came as a result of the development of new domains, such as the 5G and the Internet of Things domains. And problems such as identity theft and data leaks should be overcome by using new technology if this is possible. So by using the blockchain technology, well, this technology has a lot of advantages, such as its immutability and the decentralization fact. It doesn't require a centralized authority in order to maintain the digital identities. Moreover, there is a lot of interest in this technology, both in the academia and in the software development domain. And last but not least, the blockchain technology was proposed as a possible solution to the identity management problems. And we were interested in knowing if it can be used or not. So we were interested in knowing how developed are the identity management blockchain-based solutions that were proposed, if they are at an early stage or they are used in production, which solutions seem to be more used by users, if those solutions can solve some of the identity management problems or not, why should the user choose a particular solution or another, and which solutions seem to be more secure. Our research began with analyzing 10 of the most promising identity management blockchain-based solutions that were proposed, and our findings were published in Identity Management on Blockchain Privacy and Security Aspects. So this analysis involves the privacy and security aspects of those solutions. We found that they are at an early stage, not very used in practice, have implementation flaws, and more analysis needs to be done in order to overcome different challenges of those solutions. Moreover, some of those solutions could face identity problems due to their privacy by design architecture, and the great deal of responsibility is in the user's hands. So the user is having a lot of responsibility using some of the applications. After analyzing those solutions, we found out that two of them seem more developed at that time, the U-port solution and the sovereign solution. And furthermore, in our research, we decided to analyze the U-port solution. We analyzed the code using analysis tools in order to scan the smart contract vulnerabilities. We collected and analyzed the blockchain identity registry transactions to the U-port registry. We found out that the on-chain usage of the solution is relatively low, which can be expected because this mainly intended as an off-chain solution. And last but not least, there are available libraries for developing solutions based on the uport open. And there is also mobile application developed by the company, but it is only a prototype, and it should be modified in order to obtain a production solution. So even the uport, which seemed to be more present in the virtual world, needed some adjustments, which we discussed with the uport team, and they were really open to discussion. Furthermore, in our research, we analyzed the possibility of using some privacy-preserving techniques to enhance the blockchain identity management domain. Namely, we analyzed the using of zero-knowledge proofs, succinct non-interactive arguments of knowledge, and succinct transparent argument of knowledge. We analyzed the available libraries for zk-SNARKs and zk-STARKs, and we proposed some zk-SNARKs simplified examples for user identity management real-life cases using the Remix ID Zocrates plugin. We found out that those are promising privacy-preserving techniques, but not mature enough for using in a production environment. So more research needs to be done in this area. And the analysis in terms of the setup time and proof generation time, as well as transaction costs, was done for those proposed examples. And the transaction cost, so the real Ethereum cost, was rather acceptable for those programs. So there are very promising solutions which in the future could be also used in production environments. So at this point, we answered some of our questions. Some of them also remained, such as which solution seems to be more secure, or why should the user choose a particular solution or another. In our research, we also published some on the social impact of the blockchain technology. Some were related to my PhD thesis theme, which can be seen in the paper. And as the possible future directions, we identified some directions in writing the previously mentioned papers. And these are whether quantum-resistant blockchain primitives can be used for blockchain identity management, and how can we use those primitives. To propose self-sovereign identity blockchain implementation of data preservation, which this point was actually done in the last months. A new paper will be published in this area. And also another 2 points which will be of interest in our research is involves the demographic user behavior of the users using the blockchain identity management solutions. And also is the last future direction will be to propose an identity management privacy preserving framework. These are the mainly directions which we identified in our research. Thank you for your time, and if you have questions.